We're going to take a look at example 4 from section 4.3. Here they give us the graph of f prime, and from that we're going to be asked some questions. The first one is, on what intervals is f, the graph, what intervals is the graph of the function f increasing? And we have to get that from the graph of f prime. Well, when f prime is greater than 0, f will be increasing. So f prime is greater than 0 from -4 to -2, and then from -2 to 1. So those are the intervals in which f prime is greater than 0. But because this function is continuous and it only just hits 0 here, f prime hits 0 here, and is immediately again positive right afterwards, f will be increasing over this entire interval from -4 to 1. At -2, what you will have is a horizontal tangent, and it'll be a shelf. And you'll see that when we look at the graph of f a little bit later. But it's increasing. You can say from -4 to -2, and then from -2 to 1, but it's really increasing all the way from -4 to 1. And so that's our answer. And we'll again look at the graph later. On what intervals is f concave up? The function f is concave up when its second derivative is positive or when it's greater than 0. Well, f double prime is greater than 0 when the graph of f prime is increasing. So when is this graph of f prime increasing? Well, f prime is increasing from -2 to 0. So that means the slopes of f prime will be positive, and thus f double prime is positive or greater than 0. It's also increasing from -3 to 4, and so f double prime will be positive from 3 to 4. So the intervals in which f is concave up will be from -2 to 0 and from 3 to 4. Part C, where are there local extrema? Well, there's a local max at x equals 1, and that's because f prime changes from a positive value to a negative value. So f prime changes from positive to negative, which means f will be increasing up to 1, and then it'll be decreasing after 1, and there'll be a max at x equals 1 because f prime changes from positive to negative. There are no other places on the graph in which f prime changes sign, so that means there are no other local extrema. Even though f prime equals 0 at -2, there is no extreme value there because f prime does not change sign. The function f would be increasing when f prime is positive, and then it's increasing again after -2 because f prime is still positive. So that takes care of part C. Now, part D says, where are all the inflection points? Well, inflection points are going to happen when the second derivative changes sign. Well, the second derivative will change sign when f prime will change from increasing to decreasing or decreasing to increasing. So f prime is decreasing here, which means the second derivative is negative, and then it's increasing here, which means the second derivative will be positive. So we'll have an inflection point at -2. We'll also have an inflection point at 0 because f prime is increasing and then f prime is decreasing, which means the second derivative is positive and then the second derivative is negative. So second derivative changes sign. We'll have an inflection point at 0. We have another inflection point at 3 because f double prime will change sign there also, because since f prime is decreasing until we get to 3 and then f prime is increasing after 3, that means the second derivative is going to be negative, and then the second derivative is positive. It changes sign at 3, so we have an inflection point at 3 also. So that takes care of the first 4 questions. In part D, we're asked to sketch a possible graph of f on the interval from -4 to 4. I put down all of the important information we found from the first parts, plus I added the information that we're concave down on these intervals because of the same reasons when we figured out it was concave up. It's concave down because the second derivative will be negative, and the second derivative is negative because f prime is decreasing on these intervals from -4 to -2 and from 0 to 3. I also added that F is, they didn't ask us, but I added that F is decreasing from 1 to 4, and that's because F prime is negative from 1 to 4. So utilizing that information, I am now going to put it all together. So we have the information here that if we combine the information from up here and kind of put it together with when it's increasing and what its concavity is, we know that it's increasing and it's concave down from -4 to -2. It's increasing and concave up then from -2 to 0. And we get all that information from, up here. It's increasing and concave down from 0 to 1, decreasing concave down from 1 to 3, decreasing concave up from 3 to 4. After I have put that information together, I now come over here, and on these intervals, the first one was -4 to -2, I draw a little piece of what my graph would look like. It's increasing and concave down, so it has to be some type of a shape like this. And then the next interval was -2 to 0, in which it was increasing and concave up. The next interval was 0 to 1, and it's increasing and concave down. And then the next interval, decreasing and concave down. And then the next one, decreasing but concave up. So we have changes in concavity here. We have changes in concavity here, change in concavity here. Okay, so as we start to graph that, we have to keep that in mind. So I'm going to go ahead now and we're going to start our graph. So we'll start at -4, and we're going to draw this piece right here. We could really just take this piece and we could move it up, but we'll just go ahead and draw this now, since you wouldn't have that option on a piece of paper. So but we're basically going to look at that. So I got to keep in mind I'm going from -4 to -2, so I'm just going to kind of come up, and let me change that color to red and erase that. We'll go with red here so you can see it better. All right, here we go. So we go from -4 to -2. It's going to go concave down and increasing. And at -2, we know that there was a horizontal tangent, the derivative was 0. And we're going to change concavity now, and it's going to go from -2 to 0, concave up. And at 0, then we're going to change concavity and go concave down. We got a max at 1. It's going to go out. Now it's going to come back down, and it's going to stay concave down until I get to 3. And then at 3, it's going to start concave up and still decrease. So that would be not bad. I think right here, I probably didn't do a very good job of my inflection point changing. It looks like it's changing here more than it is here, but it's supposed to be changing at 0. But overall, that's not too bad of a looking graph. It's not easy to do, but as you can see, I did have it concave down and increasing, and there's an inflection point, change the concavity. Now it's concave up and increasing. That's supposed to be the inflection point there. Concave down, increasing, hit the maximum, and now it's concave down and decreasing, and staying concave down until we get to 3. Now it's concave up. There's an inflection point about right here, and now it's concave up and decreasing. So that's what we're trying to do there, is be able to sketch that graph, and that's how you want to do it. The biggest thing is making your pieces down here, looking at when it's increasing and decreasing and what the concavity is, and then making those little pieces, and then putting all the pieces together to make a graph.